people expected robots can do everything. Even we released a lot of cool videos, which the robot can do some dance, kung fu. It's still very early stage. So my name is Tony Yan. I'm responsible North American market from Unitree Robotics.
At Multiple Labs, we developed advanced systems to manufacture drugs. What we have found out in every part of the process where there are still human operators, that becomes almost automatically the bottleneck.
So we think the biggest challenge for robots is the software and algorithm. So there is not a robotics model which can work for robot can understand the physical words.
Our robots are so fast that even loading becomes the bottleneck. A general form factor like a humanoid is actually a great solution for it.
Wow, the vision which we have is that we expected the humanoid robot can realize the general task, which means that in the near future, everything's got to be free.
When I was a grad student, which is not too long ago, I remember in MIT when there was the DARPA Grand Challenge for robotics, there were 20 PhDs around a single humanoid, right? Cost has gone down so much for the hardware that you can actually develop software and new skills and reinforcement learning and all these new approaches. The only limit that's left is how fast the robots can learn new tasks. Yeah, it's real. It works. It's here. Human robots are really ready to be applied. Thank you very much for being here. Welcome to Multiple Labs. It's a pleasure to meet you. I am Fred, co-founder and CEO of Multiple Labs. And this is our new office.
So my name is Tony Yan. Thanks for invitation. I'm responsible North American market from Unitree Robotics. It's glad to be here.
Thank you, Tony, for being here. And of course, for bringing here also our new friend, the G1, Unitree's humanoid robot. I would say kind of teenager-sized, and it's fantastic to see, in person that this technology is, here and ready to be deployed. Okay, so in this conversation we have a few cards, and these would be questions for me or for you randomly that we don't know, about. So let's see, what's the first question? What's a moment, either early in your career or recently, where you thought, wow, robotics really will redefine everything? You want to start?
Yeah.
Okay.
Yeah. Actually, a lot of people expected robots can do everything. So even we released a lot of very cool videos, which the robot can do some dance, kung fu. From those videos, actually, it's still very early stage for robots to define everything. So we think the biggest challenge for robots is the software and algorithm. So there is not a robotics model which can work for robot can understand the physical words. So that's the biggest challenge at the moment. And I think the hardware probably still have some challenge, but it's not a very big challenge. Like the battery life, like the operation time for the robot. I think the hardware can be upgraded very fast in 1-2 years, but the software probably need even more time.
Yes. I mean, definitely, I completely agree that, the hardware is getting there very rapidly. And now it's enabling all of these applications, which are, software enabled. I mean, when I was a grad student, which is not too long ago, let's say 7 years ago, and, working on a humanoid robot, you needed 20 PhD students, and the cost per robot was a couple of $1 million. I remember in MIT when there was the DARPA Grand Challenge for robotics, there were 20 PhDs around a single humanoid, right? And now, thanks to you guys at Unitree, I mean, it is, the cost has gone down so much for the hardware that you can actually develop a software and new skills and, reinforcement learning and all these new approaches so much faster. So I have to say that, when I saw, your announcement about the G1, I was like, wow, at that price, these should be everywhere. And this is actually, I think it was a very important moment. So, I mean, thank you very much, guys, for being here and making this product.
Yeah, thank you very much. So,
yeah, humanoid robots capture the imagination, but what's a practical, even surprising application for humanoid robots in pharmaceutical environments that you can envision? So, at Multiple Labs, we developed advanced systems to manufacture drugs, what we have found out that in every part of the process where there are still human operators, that becomes almost automatically the bottleneck. And so a very important part of our process where we saw that was loading and unloading our robotic systems. It is a very practical application. It's just, picking and placing, boxes, loading basically the rest of our robotic systems. But right now we were doing that by hand. And we thought, well, it's an easy task. It for sure will not be a bottleneck. Well, our robots are so fast that even loading becomes the bottleneck. And so to me, it is like a simple application, pick and place of vary the range of boxes. And then after picking the box, move it and then load the main robotic system. Very practical, very simple. And a general form factor like a humanoid is actually a great solution for it.
Yeah, so actually, from my point of view, the humanoid robot can be a general platform which you can add a different sensor, or you don't need to change a lot of equipment for those type of robots. So the robot can be with imitation learning, so they can do a lot of tasks which is very familiar, similar to human. At this point, we say, especially after in 2022, so after the GPT is coming, so we think the generative AI move very fast, which also helps the humanoid robot move very fast, and is over we expected. Yeah, that's why we say the humanoid robot technology can have a big potential for the future.
Exactly. The impact is gigantic. I mean, it used to be that the limit was the cost of the hardware, but you have proven that, that is not a limit, in fact. So the only limit that's left is how fast the robots can learn new tasks, right? And that is a place where, yes, the new generative approaches, the new reinforcement learning approaches, they basically can really unlock a lot of new features on the same hardware. And this is where essentially having general purpose hardware really helps you, like a humanoid, because a general purpose humanoid can learn a lot of tasks, right? Provided, of course, that you can afford to deploy it. But thanks to products like the G1, that is possible.
Yeah.
This is great. Honestly, when I was a student, I would have loved to have this conversation. So I'm kind of seeing myself in the future. It used to be a dream to have hardware like this to work with. Okay, so in manufacturing, rather than just automating existing processes, how could robot radically reshape business models, supply chains, or even customer relationships? Oh wow, that's a very big, a very general question. Wow.
So actually, we already see a lot of industry robots deploy thousands or millions factory to do the automation, all the manufacturing processing. So this is what already happening in the industry robots. But for humanoid robots or quantum robots, so that actually very important part for humanoid robot is happening is that they have a need to collaborate with human or interact with human. So which we found recently, a lot of customers planning integrate with large language model with the humanoid robot. So they have a capability to talk with people, to interact with people. So this is a very important part and different compared with the industry robots. So the humanoid robot have those capabilities, and he can build the relation with human. That means it's not just a working machine. So he have emotion. He have he need to as a companion, or maybe that's the future is working at your home. So as an assistant or AI agent assistant for you.
Yeah, absolutely. I mean, even just before when you did the demo downstairs, and these are all robotics engineers that, you met here. So these are experts, but yet because it has the form factor of a person, right? And so you actually can understand what it's going to do way more rapidly, right, than you would with a robot that's designed on purpose. Like a specific robot can typically only be understood by the engineers that developed it. But a robot that behaves like a person can actually immediately interface in a much easier way with untrained personnel. So I think in manufacturing, for example, on the pharma manufacturing floor, right, there's going to be a lot of people that are going to, clean or, supervise, or scientists. None of these people is a robotics engineer, but if they work with robotic humanoids, basically, they are going to know at a glance what the robot is doing, right, if there's any problem, right, because they're used to working with other people. So I think this is just, a profoundly new way for robotic systems to interface with humans. And it's just fantastic. I mean, it's really the future. And, I'm very, very happy it's here.
Yeah, right.
This is great. Next question. Oh, yes. What valuable insight or experiences from industries like automotive, aerospace, or entertainment could be relevant to pharma robotics? And what unique challenges does the space present? So I think the applications of, humanoid robots to traditional, let's say, automotive or aerospace manufacturing are, I think pretty straightforward. In pharma, there is a next level because these are products, these are drugs that then go in a patient. And so they have the potential to cure, but if something goes wrong, then you can really damage. It's life-saving drugs. So there's two things where, a robotic system can really, really help even more, I think, in the pharmaceutical space. Number one, robots are not sources of contamination. Normally in pharma, whenever there is contamination, it always comes from people because people did not put on the gloves, they touched the wrong thing, they sneeze, they need to go to the bathroom, all these things, right? The robot doesn't do that. This is not a system that's conducive to the growth of contaminants. So it's a huge need for pharma that a robot like this, and really any robotic system, can basically immediately bring to pharma manufacturing. The second part is pharma manufacturing is very manual. Right now, most next generation therapeutics manufacturing is done by scientists in clean rooms. So there's always a scientist that goes around and shakes the flasks, moves the bag here and there, opens the incubator. It's all done manually. And so it's very natural to translate that into either a multi-joint robotic arm or directly a humanoid robot. But these are tasks that are done by humans today, and therefore it is reasonable to automate them with a human-like form factor, either a robotic arm or a humanoid. On the other hand, in car manufacturing or aerospace manufacturing, a lot of the tasks like injection molding, right? The big press, it's not designed for people to work in there, right? It's designed to be a big machine that works on its own. So there, a humanoid form factor is less useful. But in pharma, everything is so manual that a form factor like this can be really useful.
Yeah. So I think one of the opinion you mentioned, the robot can be at a very clear environment. So the robot is a perfect form.
Perfect.
So, yeah, but they also have some we think we call 3D, dangerous, dirty, or difficult. So which those 3D environments. So we think the robot can be also deployed.
Yes.
And one more important thing is that some repeatable task, which is human, it's very hard to consistent to do those repeatable tasks. And the robot is always stable to continue to do those repeatable tasks, and very suitable for the robot to do that.
Yep. No, absolutely. I mean, the applications of these form factors, provided the hardware is scalable and reliable, which it is, clearly it's here with us today. It's pretty much endless. And you're right, especially together with the new generative models, right? Together with access to that information. It's very key. I mean, I guess the tricky thing in pharma is that there's much less tolerance for errors than in any other field. So if you're bringing a glass of water and you drop the glass of water, that's not a big deal. If you drop a cell therapy product, that is a $500,000 mistake at least. But that's just a technical challenge. How do we make these systems reliable enough? The potential is clearly there.
Yeah, right.
See, another question.
Yeah, this one should be fun.
how does the role of humans working alongside the robots shift in a world with advanced robots? Is this different for more high-skill industries? That's a very good question. What do you think? Who should go?
I hear from the people who brought the robot, himself.
Yeah, actually, I think when we're talking about the robot to do different tasks, as I mentioned, for like industry robots, so they already did a lot of different tasks at the manufacturing factory or even logistic. So like logistic AMR, AGV already during the specific task. But for humanoid robot, we haven't say with large deployments. So actually, we think the humanoid robot probably need step by step from very simple task or maybe repeatable at especially for the pharmacy environment production. So those can be step by step. And once the specific environment, the robot can be trained easily to finish the repeatable task. And then next generation, I think we probably can generalize the task to be multiple different scenario, which is a very like a human. You teach the experience to the robots, and the robot can understand what its general task means, and he can do like a lot of DEX manipulation for a very complicated task.
Exactly. I mean, from my point of view, the best tasks for robotic systems are the tasks when you tell people, oh, you know what, we can actually train a robot to do that. You see the relief on their faces, like they don't want to do that job. This is true for the dirty, dull, dangerous, jobs, but it's also true for the super high stress, high precision, no contamination task in the pharma industry, right? Like, for example, to load our robotic systems. Like, every time we ask an operator or one of our engineers to load the robotic systems, that is actually a very boring job. Like, nobody wants to do that job, right? And so when we tell people, well, actually we can train a humanoid to do it, overwhelming answer is, oh, thank God, which means that the relationships, on the workplace is, we need to develop the robotic systems that are doing those tasks that are just not honestly interesting or practical or efficient done by hand. And typically those tasks tend to be the most boring tasks, because maybe pharma manufacturing is not dangerous or dirty. Actually, it's super clean, but for sure it's very dull. And so replacing that, with, automation actually enables the scientists to actually supervise essentially a fleet of robots doing this task. And I just think it's completely unavoidable, right? I don't think anybody can see, a humanoid robot or one of our pharma manufacturing systems and then think, oh, you know what? I think we should continue making drugs by hand. Like, it's just not possible anymore. Okay. What is the biggest leap of faith companies must make to fully embrace robotics, especially humanoids, and how do you build that trust? Well, I can start a quick answer. For me, as an engineer, the answer has always been the proof is in the data, right? And so, all that we have discussed is reasonable in theory, but what are the data showing that robots can do these tasks with this performance at this price point? And so that's why I really appreciate what Unitree has done, because not only you built a humanoid, many people can build a humanoid, but you're selling them at a price point that makes it impossible to ignore. On the multiple lab side, not only we develop robots that manufacture drugs, we actually publish together with UCSF, together with our partners at Stanford, the data showing that the robots can actually grow the cells. And so once the data is out, performance data, price data, it becomes undeniable. Before the data is out, it's just an empty promise. And so I really, I'm very happy that modern robotics companies are actually showing people the data to believe. It's not a leap of faith anymore. You just need to look at the data.
Yeah. So I think from another point of view, to build the trust between robots and humans. So I think one of the important things we need to look at why human can make a mistake, or sometimes they have that is because of the motion.
Yes.
So human have a motion, but robot will never happening from this point of view. I think a robot at the moment do not have a motion. So that means they can always working following the people command, fully transparent. We build this robot is purely to do task. It's not to have a motion. Yeah. So at this stage, I think one of the things is data, and another thing is the robot is built for human to do to do all the tasks. It's not have a motion, so it's not like human. So most of the mistake made by human, it's come from the motion, I think.
Yep.
And another thing is that to do the like a very repeatable or like a complicated task. So those is like a pre-programmed functions, which the robot can. You don't need to worry about the robot have some go through other ways which you were not pre-programmed. So that is still not, you need to worry about that.
Yep. Yeah. No, it's true. And it's also very funny that, of course, we build trust by showing the performance, the data, from the robots. But it's also true that it's very tempting sometimes to say, okay, so you want the data to trust the robot, here the data, but can we actually trust people to make the task in the first place? And so, in other words, the basic manual task typically has a very high error rate because people make mistakes all the time.
Yeah.
But we learn to be very, delicate and gentle. So we typically don't ask, our customers, hey, how many mistakes do your people make? That's not a good question. But we know that a lot of mistakes get made and that robotic systems make way less. If you could collaborate on one Moonshot project, cost and feasibility aside, what would you love to create and why?
Yeah, so I think one of the vision which we have is that we expected the humanoid robot can be realize the general task, which means that opinion from same as Elon Musk. So he said, in the near future, everything is gotta be free. So that means the robot can be produce everything initial for the human, or maybe build the house or produce the food. So you don't need the human probably don't need to work for that. That means the human can do much more, like follow his interests, and that is a very big vision, I think, for human, which is generalize humanoid robot to do a lot of different tasks. Yeah, I think that is a very big innovation for human in the near future.
Yeah, no, that's basically the promise for robotics, creating valuable things for people so efficiently, right? And from the point of view of Unitree, of course, what about every task in the real world, building houses like you mentioned, taking care of the home and so on. From the point of view of multiple labs, it's always been, well, what is the most valuable thing for people where is being healthy, right? And therefore, if we apply robotics to the manufacturing of life-saving therapies, we are essentially helping making these, products as available and, as free, as close to free as possible, right? And right now it's not the case. That's definitely the vision, that this sort of technology enables positive value for society at a degree that's basically not seen before. Honestly, it's very good to see that, leading in companies in the space like Unitree are very aligned on this. It's about pharma. It's about helping in the house. It's about helping, building, right? It's just very inspiring to see so many people that want to build positive things for society. Maybe we start answering the final question and then the G1 kind of walks in.
Oh my God.
I mean, this is fantastic. So I guess maybe let's answer. Okay, so final question. What's the most surprising insight you gained from today's discussion? Most surprising insight. I was expecting it, but it's always different in person. It's real. It works. It's here. Humanoid robots are really ready to be applied to the cutting edge of manufacturing. And it's really, really impressive to see the G1, here in person. moving around, shaking hands, interfacing with people. So nice to meet you, G1.
Today I got some very interesting insights from the discussion. I'm visiting a lot of customers, different customers. But then I haven't say that the deploy the robots for pharmacy production. This is a very special industry which use robots. I think it's also a very big innovation for the both robot industry and also the pharmacy industry. So which I think have a great potential to scale the robots to do production and help build the better life for human.
Yeah.
Oh my God.
Is it? Am I still in the frame?